Hi everyone. Today we are going to discuss about the orthographic projection of lines. In this question, the line is inclined to both reference plane. That is, it is also inclined to the horizontal plane and also inclined to the vertical plane. We can find out how to draw the orthographic projection of the line inclined to both reference plane. The first type in this question, the true length, that is 100 mm long, that is the true length of the line AB. It will be given, and the 30-degree inclination with HB, that is known as the theta, and 40-degree to VP, that is known as the phi, is given. And also the end A is 20 mm above HB and 30 mm in front of VP. So this is a type 1 question. This is straight question. All the details are given here. So at first we need to draw the XY line. Now we need to mark the point A. Here the point A is 20 mm above HB. So this portion is the VP and the XY line below portion is known as the HP, the horizontal plane. So above HB means we need to draw 20 mm above. We mark the 20 mm above here and 30 mm in front. So here the in front of VP means it is in front of your palm. Behind means it will be behind your palm. So 30 mm in front we need to draw below the XY line. 30 mm behind VP we need to draw above the XY line. So here we just draw 30 mm in front. So draw it with thin lines. We can mark here. This is A dash. That is the elevation of the point A. And here it is A. That is the plan of point A. Now we need to draw locus line of A dash. It will be parallel to the XY line and locus line of A. So that will be also parallel to the XY line. Now we need to draw 30-degree inclination to the HP. So that will be here with the length 100 mm. So we need to take the 30-degree inclination. We draw the 100 mm line over here. So this point is known as the B1 dash. Now we need to draw the locus line over here also. Now we need to draw a line perpendicular to the B1 dash to the locus line of A. So this is the B1, the plan of the point B1 dash, and this length is known as the plan length. Plan length. This is the true length, 100 mm. This inclination is known as theta, that is equal to 30 degree. So we get the plan length over here. The next thing, we need to draw the VP inclination here. So the VP inclination is 40 degree. So the VP inclination is always drawn from the point A or B, only from the points the plan. The HP inclination is always drawn from the elevation points, that is A dash, B dash, that is the point above or below HP. The VP inclination will be from the point in front or behind VP. Now we take 40-degree inclination. Now we need to draw the locus line from the point B2. So this is the point B2. Then we need to draw the elevation point of the B2. Draw the line perpendicular. So this point is known as the B2 dash, and this length is known as the elevation length. This length up to here is the plan length. This length from the A dash B2 dash is the elevation length. Now we need to rotate the elevation length to the locus line, and we need to rotate the plan length here, the B1, to the locus line below. If our drawing is correct, we get this line perpendicular to the XY line. So here it is perpendicular to the XY line. So we can conclude this point is the B dash, and this point is the plan of B. Now we just need to connect the points. We can use thick lines for that. So this is the elevation length. This angle is known as the alpha, the angle with the elevation length to the XY line. This angle is known as phi, 40 degree, which is given here, and this angle is known as beta, the plan length makes with the XY. Here this is the true length. Here the plan length. Then we need to find out the distance of the elevation length and the plan length. We can find out that elevation length is equal to 77 mm. The plan length is equal to 87 mm. Here we plot the distance. We can mark it here. It is given in the question 20. Here it's 30. So elevation length, plan length is noted. Now we have to find this angle also. So the alpha angle is 41 degree and the beta angle is 48 degree. The true length is given, that is 100 mm. So these are the end projectors of the line. We can also mark the distance also. End projectors distance is 58 mm. It is the distance marked here. Fifty-eight mm. That is the end projectors distance. So in this question, we draw the elevation length and we find out the elevation length and the plan length. Now we are going for the type 2 question. In the type 2 question, you will given the true length, the elevation length and the plan length distance. Not the theta degree and the phi will not be given. So anyway, we can find out a relation in this. So it's like a puzzle. The elevation length here will be just above the plan. B dash will be above the B. And the plan length we drawn here is always be parallel to the xy line on the locus line of B. And we can find out a perpendicular line here. So that is a relation. We can find out a relation when we draw parallel line here. When we draw the perpendicular, we can cut the true length. And also when we draw the elevation line parallel to here, then a perpendicular line projection, we can cut the true length over here. So that is the idea to draw the second type of question, that is the top view of a 100 long line. So this same question is asked in a different way. Measures 87 the front view measures 77 the end A is 20 above HP and 30 in front of VP. Find the apparent inclination and true inclination of the line. So this is known as the type 2 question. So the same question previous to the we done earlier, we can see that the point A is 20 above and 30 in front, and we also find out the true length. The elevation length is 77 the plan length is 87 it is given here. So we will get the same figure here, but we are drawing in a different way. Now here we don't know the inclination to start with, but we get the top view length, that is 87 mm. In previous problem, when we draw an inclination line 30° here with the true length, we get the plan length parallel to the xy line on the locus line of it. So that's our tip. We need to draw the top view over the locus line of A. So we mark the 87 mm here. Then we need to draw a perpendicular line. So in this line, we can cut 100 mm, the 10 centimeter. We take the point over here to plot. So we take the distance 100 mm. Now plot here. We can connect here. Yeah, this is 100 mm. So here we will get the inclination. Here the true length, that is 100. Here we will get the plan length 87 mm plan length, and this point is known as the B1 and this point is known as the B1 dash. Now we need to draw the locus line from B. Similarly, we need to plot the elevation length over here, which is on the locus line of A dash, and we draw the perpendicular here and we will get the true length over here. Here the distance is 77 mm. So here that is the elevation length 77 mm. Now we check for the perpendicular line. Now we need to cut the 10 centimeter 100 mm from the point A. So here we will get the true length. So this is the true length 100 mm. This is the elevation point, that is the B2 dash, and here it is the B2. Again we need to draw the locus line over here. So now we can rotate the elevation length to the locus line and the plan length to the next locus line. Now we can check the perpendicular. If we have drawn correctly, we will get the perpendicular. Yes, here this will be perpendicular. Now we can connect the 2 points with thick line. So this is the B dash, this is the elevation length, and here the plan length. And we can check the angles. Here it is 30 degree, that is theta. Here this is alpha, that is 41 degree. Now we can check here. Yes, so this is phi 40 degree, and this one is beta, that is 48 degree. And we can mark the dimension over here with thin lines. 30 mm in front and 20 mm above. So the first question and the second question, we get the same answer. Now we are going for the third type of question. So the same thing we will get, but the question is asked in a different way. Here the line AB has a point A is 20 mm above HP and 30 mm in front of VP. The point B is 70 mm above HP and 94 mm in front of VP. The distance between the end products is 58 mm. Draw the projections and find out the true length of the line. So here we will get the distance of B dash from the XY line, and we will get the distance of B from the XY line. Here it is 94, here it is 70, and the distance between the end products, that is 58 mm, that is also given. So that is the third type of question. We can answer that. The first step is common. We need to draw the XY line. So this is the point A dash, and this is the point A. Now after 58 mm, the end product distance is 58, so we need to take the 58 mm over here. 5, 8. Then we check for the perpendicular and we have to plot the distance B. So it is 70 mm above and 94 mm in front. So this is the point B dash and this is the point B. Now we can connect this right away. This is the plan length and This is the elevation length. But we didn't find the true length yet. So the plan length and the elevation length we already get. So we need to find out the true length. So for that we need to draw the locus line from every point. So that is very important. We need to draw the locus line from A. We need to draw the locus line from B, from A dash and B dash. Now to find out the true length, we need to rotate the elevation length and connect to the locus line of B. Similarly, we need to rotate the plan length and connect to the locus line of B dash. This is the reverse process of the type 1. We rotate the elevation length and draw the perpendicular. So this is the true length. We can check, yes, it's 100 mm. Similarly, we have to rotate the plan length and connect to the locus line. Now we check here. Yes, it's again 100 mm. So this is the true length. Now this point is known as the B1 dash. This is B1. This is the B2 and this is the B2 dash. Here the end projector distance is 58 and we can check the inclinations. It's phi, that is 40 degree, and the beta, the inclination with plan length, beta is equal to 48 degree. We mark the dimensions over here. Here it's 20, here it's 30. The end projector's distance, it's 58. End projector's distance between the projector of A dash and B dash, 58. We can dark the line of elevation length and plan length. Now we can find out the trace. So in order to find out the trace, we just need a formula like this. The elevation length, that is A dash, B dash, H dash, VT lie on a line. Similarly, the plan length A, B, V, HT lie on a line. V and H dash will be on XY line. V perpendicular to the vertical trace, H dash perpendicular to the horizontal trace. So a trace means when we extend a line and this will touch on a point on the reference plane. If it is touching on the horizontal plane, that is the horizontal trace. If it is touching on the vertical plane, that is known as the vertical trace. And V is the projection to the XY line, and H dash is the projection from the HT to the XY line. So we just need the extension of the line, elevation length, A dash B dash line extend, just extend, and this point is known as the H dash. Similarly, extend the plan line. This point is known as the V. So this is V and this is H dash, because we know the extended of A dash B dash will be H dash, A dash will be H dash. The extension of plan AB will be V. Now draw a perpendicular from the H dash. We will get HT. So this point is HT. Now we can look around. A dash, A, B, V, HT lie on a line. A, B, V, HT lie on a line. And we just draw another perpendicular from V and connect it to the extension. So this is VT. So we can check the rule. A dash, B dash, H dash, VT lie on a line. A dash, B dash, elevation length, H dash, VT lie on a line. So this is the trace of a line, and the trace makes an angle similar to the alpha. Vertical trace line makes an angle alpha. The horizontal trace makes an angle beta, and the distance here, the vertical trace is, yeah, 3, and next one is 4m. Okay, so that is about the trace. Now we are moving to the fourth type of question. The question will given with the trace. So in this question, the elevation length, the A dash, the trace distance will be given. So we can draw a line over here. So the question is like this. The front view of the line measures 77 mm. The end is 20 mm above the HP. The vertical trace is 3 mm below the XY line, and inclined front view makes 41 degree with the XY line. We have to find out every other measures, and the phi, the true length, inclined 40 degree with BP. So how to find out? At first we need to draw the XY line. The end is 20 mm above HP, so we can mark that. We check the perpendicular. We mark the 20 mm over here. The next point is not given, so we can draw a perpendicular line. So this is the point A dash, and the length is given 77 mm, which is the elevation length, and the angle is also given 41 degree. So we need to take 41 degree. So before that we can draw the locus line. So that is the locus line of A. Now find out the angle 41 degree. That is the alpha angle. Then mark the distance 77. This is 7, this is 77. Now we can draw the locus line over here. So this is the B dash, and here this is the elevation length, and this angle is known as the alpha. Then it is given the vertical trace is 3 mm below the xy line. So we can mark the 3 mm line below the xy line. We connect the point. So just draw the perpendicular. So this is vertical trace, this is V, and this is H dash, A dash, B dash. Then we can draw the vertical line from the B also, the projection line of B. So here then we get only one more information, that is the line AB is inclined. The true length of the line is inclined 40 degree to VP. The phi is 40 degree. We assume the point A is here, and we can take the 40 degree from here. So anywhere here we can find out the true length. So how can we find out? With the help of the elevation length. We can rotate the elevation length, then draw perpendicular line meeting this point. It's purely assumption. We will get a point here. Again, it's purely assumption. Please note that. So this is the point B2 dash. This is the point B2. We just draw a vertical line over here, the locus line from this vertical line. So the next thing, we know the planned length will be around this line itself, and it must lie under the vertical line of the B dash. So we just draw a line here. So this inclination and this line is the plan length line, and this inclination will be the beta angle, and this inclination will be the phi. So but we know the trace rule, that is a dash b dash, that is the elevation length, h dash bt lie on a line. Here it is obeyed. Then plan length a b v ht must be lie on a line. So here this is the point b3. This must be lie on a line starting from the point V. So we can draw a line parallel to the point V. Right? From the point V, we can draw the line. We can continue this line up to this point. So this is the original A. This is the original B. So we can draw the rest from here. The locus line. This is the plan length. In order to find out the true length, we can cut it from the distance here. And here also we can find out the true length. So the true inclination is given. We can check the distance. Yes, it's 100 mm itself. So this angle is theta, that is 30 degree, is 41 degree. Here it's true length, that is 100 mm. We can draw the line over here. And check the perpendicular. Yes. So this is B1 and B1 dash. Here it will be horizontal trace. So with the help of trace, we draw this figure also. Thank you.